Hey Geometry class, I made a little chapter 5 review video for y'all, so let's go ahead and get started on it. Alright guys, this problem is from section 5.1, and it says in this diagram, XZ and ZY are midsegments of triangle LMN. Alright, so we're supposed to find the distance of MN and ZY, knowing that this triangle right here is the midsegment triangle of our LMN. All right, a couple of properties about mid-segment triangles, or just mid-segments of triangles, is this mid-segment right here is parallel to this side right here. And then the two sides that are parallel to each other, or the two segments that are parallel to each other, the mid-segment is always going to be 1/2 the size of the side of the triangle that it's parallel to. So you can state this about this triangle, that XZ is 1/2 the side MN. Okay, so we're asked to find what is MN for part of this question. Well, we know XZ is 26.5. Plug that in. And solve for MN. So multiply this side by 2 and you've got MN. So MN in this case is going to equal 53. And you're done. Now let's do this other segment that we're asked to find, ZY. Okay, ZY right here, this segment right here is parallel to this side of our triangle. And again, ZY is the mid-segment, so it's going to be 1/2 of ML, which is 28 centimeters. I forgot to put centimeters on this. Centimeters. Okay. So, not X, but ZY. ZY. Sorry guys. There. ZY is 1/2 of ML. Well, 1/2 of 28 is going to give us 14. And we're done. Now this next problem is something from section 5.2. We're dealing with perpendicular bisectors. Okay, so in this diagram, XZ is the perpendicular bisector of WY. So two things about perpendicular bisectors is they cut the segment that it's intersecting in half. So this right here, these two segments are congruent to each other. And this intersection right here is 90 degrees. So this is what makes the ZX the perpendicular bisector of WY. Now, we can go ahead and figure out what WZ is equal to, because we also know about perpendicular bisectors is if we have a point out here on our line and it's drawn to the point that on a segment that we at the end point of our segment that we are bisecting, and this is the perpendicular bisector, then these two segments right here are also going to be congruent. Okay, so let's find WZ. First, we have to find what Y is equal to. So if we know WZ and ZY are congruent, we can go ahead and set up that 2Y, not equals, but plus 15, and that's equal to 9Y minus 13. We need to solve this. So I'm going to subtract both sides by 2y, and I'm going to get 7y. And then I'm going to add both sides 13 to both sides, and I get 28. So y here, if we divide both sides by 7, we get 4. So now, knowing that y is equal to 4, plug that back into here, and we will have the measurement, or the length of WZ. So plug that in. And WZ is equal to 23. And that's it for finding WZ. Now let's find XT. I don't even see an XT. It probably meant XY. So let me fix that. This right here, let's find XY. All right, so XY down here, we know is congruent to WX. So we can set up an equation again, just like we did before, to find WZ. So x plus 5, this segment right here, is equal to x, or 3x minus 5. All right, so let's see, we want to subtract x from both sides. We'll get 2x here, and then add the 5 to both sides, and we get this here. And then divide both sides by 2, we get x is equal to 5. Now, if we plug in what we found for x back into here, we will know what xy is equal to. So xy is equal to 3 times our 5 minus 5. So xy is equal to, let's see, that's 15 minus 5, so 10. And we're done with that one. Another thing in section 5.2 is this right here. We learned about circumcenters. The perpendicular bisectors of a triangle will intersect at the circumcenter, which is G here. So, in this one, we're asked, it says the perpendicular bisector of triangle ABC meets at point G. Find GB. I think there's supposed to be a period right there. But anyway, find GB. Well, let's find GB. GB is right here. Well, the thing about circumcenters is if we know that this is the circumcenter, then from that point to all the vertices in your triangle are congruent. So all these segments that are being drawn from the circumcenter to the vertices of the triangle, they are all congruent to each other. Okay, so if AG is 7, then BG is going to be 7. And we're done. So also, if we're asked to find what CG is equal to, well, CG is equal to BG, which is equal to AG. All of them are equal to 7. And that's it for this one. Now what I have for you next here is something from section 5.3 whenever we're looking at angle bisectors. I know that this line right here going through my angle is an angle bisector because I see 30 here and 30 here. These two angles are congruent to each other, which shows that this line, right, or this ray is bisecting this angle here. And what we're asked to find is just the value of x. Whenever we have a ray going through an angle, and you know that ray is the angle bisector, and then it is showing that this point right here, from this point perpendicular to one of the sides of the ray, or sorry, the angle, and then again from that same point, again perpendicular to the other side of the ray, these two segments are always going to be congruent. So finding x shouldn't be too bad. We just need to set up that each of these segments, that x plus 3 is equal to the other segment, 10, and solve for x. So here in this case, x is equal to 7. Now on this one, we also know that these two angles right here, again, are congruent because of some properties that I showed you over here. If this point right here, a segment is drawn from on this ray to a point on this segment, and these two segments are perpendicular to each other, and these two segments down here are perpendicular to each other, and these two segments are being shown congruent, just like I showed you over here. These two are going to be congruent. Well, again, we have angle bisectors. So to figure out what x is in this case, again, we know this angle is congruent to this one, so set their angles equal to each other. 6x plus 14 is equal to 9x minus 1. Solve for x. So here we have, subtract 6 from both sides, we'll get 3. Add 1 to both sides, we get 15. Divide both sides by 3, we get 5. So for this one, x equals 5. This one, we found x equals 7. So there you go. Those are just some properties about angle bisectors. I would suggest going back to section 5.3 and looking at that all over again. There's a theorem, an angle bisector theorem, and a converse of an angle bisector. So look at both of those and you will see that we just applied them here in these two examples. Okay, also in section 5.3, we learned about incenters. Remember, finding an incenter is finding all of the angle bisectors and where they intersect. So on this triangle, we should know that these two angles are congruent, especially if we know that this segment right here, or this point right here where they all intersect, is the incenter, as stated up here. Okay, all of those angles are congruent to each other that I just showed. Now, it says in this diagram, V is the incenter of triangle PQR. Find VS. Okay, so VS right here. If you go back to 5.3 also, there is something called the incenter theorem. And it states that from the incenter to all the sides of the triangles, it is equidistant, meaning from this point perpendicular to this line, this segment is congruent to this one and is congruent to that one. So how to find VS? If we know how to find VT, then we know VS and VU. And we have some things about our triangle here. This right here is a right triangle and that we can apply the Pythagorean theorem to. So let's go ahead and do that. I'm going to call this, oh, and remember, when applying the Pythagorean theorem, the side opposite of the 90-degree angle is always going to be our C value in our Pythagorean theorem. The other two sides, it doesn't matter if you name them A or B. So let's go ahead and say that's A. This over here is B. Like I said, doesn't matter which one's A and which one's B, but it does matter which one C is. It's always your hypotenuse, the one that is opposite of the right angle. So A squared plus B squared equals C squared. Y'all will need to know that for the test and how to apply this Pythagorean theorem. Okay, A we said was 15, and B we do not know yet, and C is 17. Now just solve for B. Well, first solve for B squared. And I have no idea what that is equal to. Let's see. Subtract the 15 squared from both sides. I do know because 15, 17, and b over here, I know that is a Pythagorean triple, something that y'all will learn a little later. That b, when you take the square root of both sides, b is equal to 8. So if b is equal to 8, then our VS that we are looking for is also equal to 8. And we're done. All right, this is coming from section 5.4, where we learned about centroids of triangles and altitudes of triangles. Remember, the centroid is found by the intersection of all the medians in the triangle. So BG is a median, CE and AF. Those are all three medians of this triangle. And the median goes from the vertex of one of your vertexes of your triangle to the midpoint of the opposite side. So we know that these segments are congruent, these segments, and then these segments are congruent. Okay, so that's enough about that. This question is asking us if we know that D here is the centroid and BD, this length right here, is 12, find DG and BG. Well, now you have to remember the centroid theorem in this for this problem here. Remember that if we know that D here is the centroid, then BD, the longest portion of our median, see this portion left over is shorter than this portion. The longest portion of our median is 2/3 of the whole length. So we can set up saying that BD is equal to 2/3 of the whole segment, the whole median, BG. So BG. Now, if you remember that, then this problem shouldn't be too hard for you. We know that BD is 12. Okay, so find, whoops, not BC, BG. Find BG. So I'm going to multiply both sides by the reciprocal of this number to get rid of 3 and 2. Now, BG is equal to, do the multiplication here. So I'm going to say that is 6, and 3 times 6, that's 18. So BG we have found to be 18. Now, we're also asked to find what DG is equal to, which is this segment down here, DG. Well, on this one, since we have the whole length is 18 and this portion of it is 12, subtract the 2. We can find that this is kind of using from chapter 1 here, the segment addition postulate that we know. So BG is equal to BD plus DG. We know BG is 18, BD is 12. So DG, subtract both sides by 12, you will find that DG is equal to 6. And there, we're done with that one. Okay, so here is a little problem, or a couple problems here from section 5.5. It asks us to write the measurement of the triangle the measurements of the triangle in order from least to greatest. So let's just start with our angles on this triangle since we have the measurements of our angles in our triangle. So let's start with Angle C is the smallest, so angle C. Just going to list these angles from least to greatest. Then angle B is the next one. Then angle A. Now, remember the theorem about this one is the side opposite of our shortest angle is going to be smallest angle is going to be our shortest side. So the side opposite of C here is AB. We can list that one. And then the side opposite of angle B is AC. List that one. And the side opposite of A is BC. And there, we're done with that. So we listed the angles in order and we listed the side lengths in order. Now this one, it does the opposite. Let's go ahead and list the sides in order from least to greatest. So DF is the shortest side. So let's list it first, DF. And then EF. And then ED. Okay, now that we've got the sides listed in order, let's list their angles in order. And remember, similar to this angles that are opposite of the shortest side is going to be the smallest angle. So this is the shortest side. The angle opposite of it is E. So list it first. Then let's put an angle on it. Then EF is right here. The angle opposite of EF, is D. And then the angle opposite of our longest side here, 21, DE, is F. So we are done with both of these problems of listing the measurements of each of these triangles in order from least to greatest. Now here we have the triangle inequality theorem. I just wanted to remind you of this because there will be a problem on your test just like what I'm about to show you. The triangle inequality theorem states the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so let's determine if I give you segments 3, 4, and 5. Is it possible for these three segments to create a triangle? And how you would use this triangle inequality theorem is add two sides together and see if it's greater than the third side. So let's do that. 3 plus 4, set up the inequality. Is that greater than 5? Yes, it is. Now do another two sides of this possible triangle. Add together 3 plus 5. And that must be greater than the third side, which is 4. And that checks out too. And then let's see, 5 and 4. 5 plus 4 needs to be greater than 3. Well, that's true also. So this right here is a triangle according to the triangle inequality theorem. Now let's look at one that is not going to be a triangle. So we can say, let's do 3, 4, and 7. Okay. So let's look at this. 3 plus 4 needs to be greater than 7. Well, 3 plus 4 actually is 7, and it's not greater than 7, it's equal to 7. So this does not work out. You can check to see the other two sides, like 4 plus 7, well, that is greater than 3. That works. And then 3 plus 7, that also works. But one of the sides, if one of the inequalities is not true, then the whole thing fails. That these three segments do not create a triangle. Okay, that's the triangle inequality theorem. Let's go. Okay, you will have a couple problems just similar to these. It asks to complete the statement with a less than, greater than, or equal to sign. And then it has explain. This right here is coming from section 5.6. In that, we learned the hinge theorem and the converse to the hinge theorem. So those are actually going to be our explanations to these problems here that we have. Let's go ahead and take a look at one. We have angle 1, angle 2. We know that these two sides in our triangle are congruent, and then these two sides are congruent. Well, we also know that their common side is congruent. Well, so the measurement of angle 1 and the measurement of angle 2, if we know that these two triangles are congruent to each other, then their angles are also going to be congruent to each other. And that's just because their angles are congruent, the triangles are congruent, so their corresponding angles are congruent. So corresponding parts of corresponding triangles, or corresponding parts of congruent triangles is how you would explain that. But the answer to this one is equals. And then for part 2 here of this example, let's look at that. We have, says segment AB, well, AB is blank and do CD. See, AB, CD. Okay, so let's look at their angles here. We know that these two segments are congruent. These two segments are congruent because they are the common side in our triangle. So what about AB right here and DC? Are they greater than, less than, or equal to each other? And we determine that by looking at their angles that are opposite of the side measurements that we're looking at. So opposite of AB is this 110. Opposite of DC is this 112. So the angle measurement that is opposite, that is greater than the other one, like this right here, or let's say this one, this angle measurement is less than this one. So the side opposite is going to be less than the other one. So right here, let's put less than. That's horrible. There. And that's how we determine whether or not segments are equal or greater than or less than each other. We need to figure out their corresponding parts of the triangles to determine equality or not equality. Okay, less than or equal to. All right, last problem of this review. Okay, so again, we're looking at the hinge theorem or its converse to determine, well, to write and solve an inequality to describe a restriction on the value of x. So on this one, let's look at this. These two sides right here are congruent. These two sides are congruent because they're in common. But this side right here is less than this one. So this side, or the angle opposite of 36, this one right here, is going to be less than the angle opposite of this side measurement. And that is what the hinge theorem states, or the converse of the hinge theorem. So to figure out the inequality, to solve this inequality, write one and solve one to write a restriction on the value of x, we state that x plus 18 is less than 52. And when we write our inequality, once we have that written, we just need to solve the inequality for x, so get x by itself. And we do that just as if this was an equal sign. And I'll tell you a difference here in just a second of treating this not like an equal sign. But in this case here, we can just subtract 18 from both sides of the inequality. And let's see, we will get 34, I believe. Yeah. And that is it for this one. Now, if we do happen to have a problem, say like this, just to kind of remind you about inequalities. Let's say we had x plus 18 is less than 52. This is a negative x. And we solved both sides, subtracted 18 from both sides. Sorry, that would be 34. Now, this right here is not positive x. We always have to have a positive variable on one side of the inequality for it to be solved. So what I was wanting to show you here is whenever you multiply or divide by a negative value, which we are about to do in this case, it switches the sign, the direction of the inequality. So to get rid of this negative value on our x, we're going to just divide both sides by -1. And when we do that, get x on this side, but we have to switch our inequality symbol to that and get -34 on this side. And we're done. Okay? So just remember that about inequalities. When you multiply or divide by a negative value, flip the inequality symbol to the other direction. And that's it. So this is a good review. And also I want to remind you of the Quizlet that I have made for everybody, that to go out and study that, because I didn't go over very much of the differences between in-center, circumcenter, and all of those other centers, orthocenter and centroid. Look at that Quizlet to further study all of those. And we're done. So I'll see you all in class and hopefully I'll do well on this test. Goodbye, everybody.